Let us see how we handle probabilities with modular signs in them. So we are seeing also that we have the constants in our PDF. We have this and also this. How do we get those two constants? So coordinate number has a PDF given by that, and the probability of this is 1 over 16. Find the constants K and C, and hence find this. So all we know that in the area under this probability, under that PDF is 1. So what I'm going to do is I'll also say now the integral from 0 to C of my f of x, which is k, x power 3, the x should be a 1. So that's what happens when you integrate this, we get x power 4 over 4 equaling 2 from 0 to c equaling 1. So when we put in, this will be k over 4 into c power 4 minus 0 power 4, which will be 1. And from there, so that our c power 4 times this k, multiply this for the side, this we shall be calling it equation 1. So that we have two unknowns and we need also two equations. So how am I getting the second equation? I come to this idea. They are telling me that the probability when x is below this is 1 over 16. But that in continuous, if I'm having 0.5 plus 0.5, it means it's the same as the probability from 0 x less 0.5 equal to 1 over 16. So now to integrate this, be now from 0 to 0.5 of my function, which is 1 over 16. To integrate that, we get k x power 4, increase the power by 1, divided by the power from 0 to 0.5 equal to 1 over 16. When we put in that, we have k over 4 into 0.5 power 4 minus 0 equal to 1 over 16. So this one is going to be k over 4. This will be 1 over 16 equal to 1 over 16. And you see that this one cancels, and so my k will be a 4 by cross multiply. So from there, after getting that, we come here and get our value of c. So from here, our k, c power 4 is equal to 4. But our k is 4. So that our c power 4 is 1. And so that our c is the same as 1 power 4. So it will be 1. So after getting these two constants, we come back and we write our PDF. It's going to be k, which is 4x cubed 0 less x less equal to 2. Now our c is 1, 0 elsewhere. So we stop that. When we come now to this probability in part B, where I have the probability less than 0.3. Now here we handle it using the idea of inequalities. Well, whenever I have x less than a, this is the same as negative a less x less a. So now it's that the whole of this is our x. So meaning if I use that idea, now my probability of, so let me handle this first. 0.3. The same as using this, we get this negative 0.3 less what is here, less 0.3, expanding it in this form here. So now we want x alone, so we take this side and it's going to become positive also this side. I have negative 0.3. So here we made x. And from here when we add, we have 0.1 less x, 0.7. So meaning that the whole of this probability of modulus this we've seen, all of this is equal to this 0.7. And so this is the same as integral from 0.1 to 0.7 of our PDF x cubed dx. And when we integrate here, we shall get x power 4 from 0.1 to 0.7. Because this 4 we are increasing the power by 4, it shall be divided with this 4, it will disappear. This will be 0.7 power 4. I mean 0.1 power 4. So the answer we get there is 0.24. That's the answer I have. So then come now to part C, where we have probability of x minus mu less the sigma. This one is treated the same way. This will be the probability of, we expand this will be now this less what is here, x minus mu less sigma, using this expression here. This will know this was modulus. Then we make this, take this side, this will be, now this one becomes positive, less x, less now sigma, then plus mu when you take the other side. And so now, where the sigma start our mu, from here our mu is the mean, then our sigma is the standard deviation. So what we're going to do, first get the mean, so that our mean is given by integral from f to b of x, f of x dx. Then come after and get the standard deviation, which is the square root of the variance. Then you put here and put here, then you get the value. You will have something like this, then you can break it like we done there. That's it, members. I wish you well.